Yes, very good. Hello and welcome back to Calculus 2, section 7.3, end of chapter 7 on hyperbolic functions. Wow. New functions. I hope you're excited. What do you know? You know polynomial functions, you know exponential, you know logarithmic, you know all the trigonometric ones, right? There is a radical and rational and all of these different types of functions. Now we get to see hyperbolic functions. So the story goes, God of mathematics called Euler, who is one of the most productive mathematicians of all time, had an idea, and there you go. Hyperbolic functions were born. So what did he do first? He found relationship between trig functions and exponential functions. So you can write sine x as e to the ix minus e to the negative ix divided by 2I, where this I is the complex I square root of negative 1. He also figured out that you can write cosine x as e to the ix plus e to the negative ix over 2. No I for cosine in the denominator. So he was one of the fathers of this complex world, complex realm. Effectively, writing one definition like this, he effectively doubled the mathematics of his time. Doubled it, all right? And these complex numbers are so cool that you are able to factor x squared plus 1, where you couldn't do that before, which is why mathematics is doubled, right? So once he, and for the most of his life, he was actually blind, by the way. So he would get like 10 scribes to sit around the conference table, and he would just dictate this mathematics and push a paper a week. So if you have $11,000 laying around and you don't need it, you can buy his collective works, which are dozens of books. Each one is like 2,000 pages of mathematics. It's called Opera Omnia. So go look it up on Amazon. Yeah. You have to have a savings account for something like that. I mean, if you want to be a proper geek. So this is what Euler did. He said, what if I remove all the i's? Would these formulas still represent anything? And then he removed all the i's, and hyperbolic functions were born. So hyperbolic functions, definition for sine hyperbolic x is e to the x minus e to the minus x over 2. If you take a look at this and the sine function, there's just complex i's are missing. Cosine hyperbolic x is defined as e to the x plus e to the negative x over 2. And those are the two most important definitions. Now let me write this in blood and capital letters too. These are not trig functions. You have to immediately make your peace with that. Trig functions are periodic. They repeat, all 6 of them. These guys, they don't repeat. Right? So, just right there, we are done with distinguishing these functions from trig functions. So hyperbolic functions are nothing like trig functions. Now, why do they have these names? Hyperbolic sine and cosine and then tangent and secant and all six, right? Well, they have a lot of cool properties just like trig functions have. So if you divide sine hyperbolic x by cosine hyperbolic x, you will get tangent hyperbolic x, which is defined as e to the x minus e to the minus x over e to the x plus e to the minus x. And that would be definition for tangent hyperbolic. And then you have cotangent hyperbolic x, which would be the other way around, so e to the x plus e to the minus x over e to the x minus e to the minus x. Let's put a green one on this one. Then we have a secant hyperbolic x, which is 1 over cosine hyperbolic x, which is very good. Let's go with blue on this one. And finally, cosecant hyperbolic x is 1 over sine hyperbolic x, which is 2 over e to the x minus e to the minus x. And for this one, we're going to go purple. There they are, 6. 6 hyperbolic functions. They're not trig, they are not periodic. So that's what we have. So now, I already said that these functions are close to trig in terms of identities. They are not the same, and clearly they can be the same because they're not periodic. Now we have hyperbolic identities which are very similar, to the point of confusion between the two actually. Very similar to trig identities. Hyperbolic identities. Number 1, cosine hyperbolic squared x minus sine hyperbolic squared x is equal to 1. This is like that Pythagorean identity, right? Except for trig was sine plus cosine, right? Sine squared plus cosine squared equals 1. Over here is this. Next one. 1 minus tangent hyperbolic squared x is equal to secant hyperbolic squared x.
Please put the square on the h, you know, put it on the, because you know how sometimes you can have sine, cube x, you don't do that.
You will put sine squared x, right? Like this.
Yeah.
Yeah, so square is there.
Right.
This is 1 unit now.
Oh, okay. Okay.
So that's the whole thing is 1 unit.
Okay.
Cotangent hyperbolic x minus 1 is equal to? Very good. You got it. Cosine hyperbolic of x plus y cosine hyperbolic x, cosine hyperbolic y, plus sine hyperbolic x, sine hyperbolic y, and sine hyperbolic of x plus y is sine hyperbolic x, cosine hyperbolic y, plus cosine hyperbolic x, sine hyperbolic y. Identities are the same, well, in some sense. Well, I'll explain the differences. Cosine hyperbolic 2x, the double angle, is going to be cosine hyperbolic squared x plus sine hyperbolic squared x. Sine hyperbolic 2x is 2 sine hyperbolic x cosine hyperbolic x. Oops. Then we have power reducing. Cosine hyperbolic squared x is cosine hyperbolic 2x plus 1 divided by 2. And finally, sine hyperbolic squared x is cosine hyperbolic 2x minus 1 over 2. Now on the side, we're just going to write that cosine hyperbolic is even. So cosine hyperbolic of negative x is equal to cosine hyperbolic of x. Sine hyperbolic of negative x is equal to negative sine hyperbolic x, so it's odd. And tangent hyperbolic of negative x is negative tangent hyperbolic x. So these are the hyperbolic identities. Do you guys see that? What happened? Down?
Down the other guy.
The other down. Number 9 is the last one. So those of you that are really good with trig identities, you already see what things. You spasm? So, do you see that these two formulas are swapped actually? For trig, 1 and 6. They're swapped. Because cosine 2x is cosine squared minus sine squared, which is that. Right? So you have to be careful. All of these formulas are there, but they are just a tag little tiny difference. Just enough to drive you crazy. This one is the same. Sine 2x is 2 sine x cosine x, right? That's the same. So number 7 is identical. And number 5 is identical as well. This one is missing a minus sign. So that's the problem right there. So these are hyperbolic identities, and you use them to prove hyperbolic identities problems. And it's the mathematical gymnastics that we do just because we can. So you would prove every single one of these identities by using the E definition, and then you use these identities to work out other identities Hello exam, right? Yes.
So there's no practical application for these?
Oh, there is. When you hang a cable for power lines, let's say cable, the curve that you get of that cable, it looks like it's parabola, but it's not. It's actually hyperbolic cosine. So electrical engineering, in terms of stretching the cables between the two power towers, you have to be very careful with that stuff because you can't stretch it too much. Because what happens when it becomes cold? What happens with things? They contract, right? So if you stretch it straight between the two, they contract and they can either rip out the tower or they just break, right? So you have to give some, but now if you give some belly to it, right? You give it some belly, what happens when the whole thing heats up? It will sag even more. And then you have a truck pass underneath, like, and rip it off. So designing these is very picky business when you have to use the Calculus2 calculations with those differentials to also figure out what is going to be the maximum sag, right, and what's going to be when it's cold, right? And so any cable that you lay out, it will arrange itself as a hyperbolic cosine. Now, you guys will eventually get to those differential equations. So you are going to see two types of equations of the second order. Half of them will have trig as solutions. The other half will have these guys as solutions. And this is not our first or last time that we are going to see this in Calculus 2. Later on, in Calculus 2, we're going to go back to hyperbolic equations as well. So, hyperbolic functions. So, yes, they are going to be back. And right now, we are learning new functions from scratch. Number one, we learned the definition of that function through ease. And now, we are learning identities. We also have domain, range, and graphs, and all of that good stuff to take care of. We do the identities, and then the pre-calculus is over. The second half of this lecture, which is still the same 7.3, is going to be on calculus. What are the derivatives and integrals on each one of these? And you will see that they line up like trig, which is great. So we don't have to work much harder. If you know your trig, integrals and derivatives, these are just going to line up nicely. And if you don't know your trig, then learning one gets you the other one, so it's like half a work. So let's work out some of those examples that will float around on your labs and exams and final and whatever. So which one of these should we prove using the definite? No, this is exam 1.
This is exam 1. Yes.
Chapter 6 and 7.
Chapter 6 and 7, yes. Oh, yeah, spicy. I know. Whew.
So we have to remember all that by Thursday?
Hell yeah.
All that by Thursday? No,
Next
this is the
Thursday.
question that I'm asking.
By next Thursday.
You have to remember this. That.
Oh, we gotta remember?
Just that.
Yeah.
Oh, then what am I writing down all the other? All right.
Oh, so we probably need to know this.
So pick a problem. Number 4 it is. Prove number 4. Great. I have cosine of x plus cosine hyperbolic of x plus y to be cosine hyperbolic x cosine hyperbolic y plus sine hyperbolic x sine hyperbolic y. If anyone ever tells you, what do you know? Just list all of these formulas. If you know them. So what am I going to do now? Well, I have to use my sine and cosine definitions. So use sine hyperbolic x is e to the x no coughing minus e to the negative x over 2, and cosine hyperbolic x is e to the x plus e to the negative x over 2. Plug in. Okay, so what do I have on the left hand side? Well, I don't have cosine hyperbolic x, I have cosine hyperbolic x plus y. So the left hand side becomes e to the x plus y plus e to the negative x plus y divided by 2. So that's my left hand side. And now we are asking ourselves if this is the same as the right hand side, and I put this question mark over equal sign. Our goal is to show that they're equal. So now I have to use these e defs 4 times on the right hand side. So cosine hyperbolic x is going to be e to the x plus e to the negative x over 2. And then the next one is e to the y, e to the y plus e to the negative y over 2. Then we have plus, and now we have sine, so e to the x minus e to the negative x over 2. And finally e to the x minus, no, e to the y minus e to the negative y over 2. Okay, so let's trace. So what do I have? I have sine x. Sine hyperbolic x is using this one, and then it lands here. Do we all follow that? Let's take a look at the last term. Sine, well, this is still sine, so I'm still using the same one. It lands here, and now variable is not x, the variable is y, so I'm using e to the y instead of e to the x. So all I did is I plugged in. I haven't done any calculations yet. Copy the left-hand side. It seems that it's in the simplified form. Equal to, question mark. And now all I need to do is to multiply these. So they're going to FOIL, right? And what do I have? E to the x times e to the y is e to the x plus y. And then I have plus e to the xy, and then plus e to the negative xy, and then finally plus e to the negative x negative y divided by 4. Or turn your notebook sideways. Plus, save your prayers, he's not here with us now. Just me. So e to the x, e to the y, minus e to the x minus y, minus e to the negative x plus y. I'm foiling like this and like this and like this and like this. So I'm foiling. And then plus e to the negative x minus y divided by 4. Yay. See, we're getting there.
This guy has some.
Yeah, there was no TV. That's true.
I was going to say something in the beginning when you said you got rid of the eyes. But that's hilarious. I was like, you sure did get rid of it.
So now, put everything on the same common denominator 4, but then hold on, can I cancel anything? Wait, what did I do over here?
We have no idea.
Yeah, what's going on over here? No one is I was testing you and you all just failed.
I was still on the first thing.
X, this is supposed to be x minus y, and this is
I was
supposed...
just thinking like, oh, he's going somewhere with it, but then you contradicted it in the second one, so then
That's why I said I was going to watch the video like 5 times.
This one, add this one, x minus y, this is minus x plus y. Holy nightmare. There we go, much better. And then what happened here? This is... Alright, so now, what do I have? I have e to the xy, that's 2e to the x plus y. Great. E to the x minus y minus e to the xy, get out of here. E to the negative xy, get out of here. And I have at the end plus 2e negative x negative y. Great. Yes, I give you identity, I say prove number 8. And I give you number 8. And then you just grind through.
We have to know
What the E, yes, for sine and cosine, that's what you have to know.
I'm gonna have to know how to prove all 9 of them.
Yes.
So you do need to know the ones from before that you gave.
No, just the 2. Sine and cosine, you don't need anything else.
Sine and cosine.
Yeah, what else do you need? Wait, sine divided by cosine. So it's E divided by E, yeah.
Okay. Yeah, it's just
Hold on, let's do some integration.
Hold on. No.
No. Here we go. Factor out 2, cancel with 4.
I forgot an E. Hold on.
You forgot an E? Plus E, factor out the minus. Ha! Same. Boom. Done. Boss.
Oh, I put too many E's.
Put too many E's. What happened? Yes. And they all work. That's the beauty of math.
Oh, I see. Okay, I got it.
Is there one in there that's like the hardest out of all of them? You know,
They're
like-
all exactly the same because you are shoveling algebra with exponential functions. They all have the same because you will use sine and cosine E definitions and just which way the algebra combines. So it looks really complicated and crazy, but as soon as you start working out these, you will see that, oh, I just plug in sines and cosine hyperbolic in terms of ease, and then just shovel through algebra after that.
Can you mark exactly what you foiled with 2?
Yes.
I am, hold on, where am I?
You have the equals with the question mark?
So look at this. This one times this one, that's the red, that's this guy over here.
Okay.
And then you have this one times this one, which is this guy over here. Then we have the green one from here to here, which is this one. And then you have the red, blue, green, what else? Purple. You got it right here, right?
Okay.
So you use foil. Oh, it's the F word. Foil. Yeah, foil factoring function. So all start with that. So color code, and then you just repeat over here. This one times this one. When you multiply the same base, exponents add. So go through.
Go the other up real quick.
The other up real quick.
Yeah. Oh, okay.
So
No. Again.
I'll leave it this way. All right.
Okay.
It is basic algebra, but it's just so much of it that it looks intimidating.
Yeah.
If you sit down, cool your head off for 2 seconds and look at it, you see I'm foiling, I am using algebra equation x to the a times x to the b is x to the a plus b. This is the only equation you are using, except now you have e to the x and e to the y, which is e to the x plus y. That's so when you put these things together, right? Please, when someone goes, what do you know? Work it out on a napkin. Watch them run in fear. Well, you have to set up the stage with pre-calc, which is this, because we are going to put an integral on this stuff. And derivative. So chain rule and use sub. No negative, just no negative, just cosine is sine, sine is cosine, no negatives.
This is a pain in the between.
Well, welcome for recognizing it. Is it hard? No. Is it annoying? Yes. There's a difference between hard and annoying, right? This, not hard at all. Yeah, you can, because you can integrate these. You don't have to integrate.
So for the exam, we should try to prove number 4.
Or 9.
I like it.
I like number 4.
Oh,
Everybody raise your hand that likes number 4.
the more hands up, more probability that 4 won't be on. Well, let's go to homework assignment and see if we can find something nice. Oh, let's not forget inverse hyperbolic functions. That's there too.
But that's not going to be on this test, right?
That's all in the same lecture. This lecture is 2 hours. We're going to have 4 breaks.
The only thing I just worried about was the first 2 that you showed me.
Exactly.
He lied.
You know, he's
Yeah, like, I mean,
no, he's right. That's all you have to remember. You just have to remember either the negative x.
That's exactly what I said.
Because that's just forward stuff.
You need to extend the homework then, because there's no way we're going to do the homework. You got to do for like 2 days.
Understood.
And you gave us all that homework last class.
I already extended it.
I'm a check.
I know you will. All right, so
I'm a check.
are you ready? But let's go, huh? 2 sine hyperbolic of ln of secant x. Lock the doors.
You did not.
Oh, really?
Yeah,
Okay.
really. Oh, wait a
Is-
minute. Let me double check.
Is equal to sine x tangent x. Yes! So now we have a hyperbolic, we have ln, and we have trig all together in one pile. Let's go.
Yay.
Why?
Why? This is called mathematical gymnastics. Just because there is zero application to this, is just look what I can do. You ever seen those guys that jump with bicycles or jump with snowboard? And why? Why?
For fun. This is not fun.
This is my version of fun, and you signed up for it, right? Did I go to your house and say, please sign up to my version of fun? No, right? As much as I would never go step on a snowboard and break my hip, right? Or hit the tree and then knock out my teeth and go all out. Right?
Wait, the sine of tangent, that's not hyperbolic?
I don't know this. So plug in and let's see.
Oh, we have to see if this. I'm going to make a prediction.
Prediction.
It's not going to. It's not going to equal.
It's not going to
Prediction.
Yes, very good. So your exponents now.
Yeah.
That x that you had in exponent is the whole thing here. So, right? Nice. Good. Let's go.
Okay, hold on.
See?
I
The
thought that
sugar
was
is kicking in.
I thought that was sine hyperbolic x and tangent hyperbolic x.
No. They are vanilla ones. Trig ones.
So So the regular guy.
Anybody know what they're doing here? Anybody at all?
Yeah, we're gonna take 2 sine hyperbolic x times ln secant x.
Okay.
Let's go. Plug it in. Plug it in. Maybe I should write the formula on the, here. Look at this. How about this? Sine
Yeah, I got it.
hyperbolic of a heart is e to the heart minus e to the negative heart divided by 2. So I don't care what's in here. Whatever is in there is going in the exponent of e. Does that help for that? Of course it does. Let's go. Cookie, anyone? Good.
Oh,
What is that?
they cancel out.
E to the
Oh,
ln
the big two in front
is
of
just
Sine?
x.
Yeah. That's the 2.
Oh, okay, so he's just saying e to the, okay.
Yeah, so e to the ln x is just x.
Let's go algebra. I know that all these problems are going to go away when we do integration. Right now, it's really tough. This is tough algebra, so it's really hard.
First of all, that just vanishes. It's 2 times.
I don't know why. It's just like I use calculus 2. Both derivatives, use substitution. I'm not doing the measure substitution. Yes, why? I feel like algebra problems. I don't know who.
I don't know how the hell you're programming that is.
Oh, like that.
Oh. All right, I'll wait till you.
All of the calculus problems solve 100%.
Okay,
The
fine.
algebra problem, no. It's like 0.
Well, you threw in the ln secant.
Yeah, because ln cancels e. 2 cancels 2. Everything cancels. You just look at it
There's
and
only
you know
one
it's done.
2 there. How can you cancel?
The 2 in the denominator will cancel the 2 in front. So, you don't have it.
I love Angel.
I got to a part where I forgot what to do. Nah, I'm stuck.
I'm waiting for you.
All
I
right,
got to my secant minus 1 over.
let's do some algebra.
He's gonna make it look so simple. Watch.
It's 3 steps.
It's not that hard.
We copy the 2.
We got that.
Got the 2, right?
We got that part.
Now, sine hyperbolic is e to the ln secant x minus e to the negative ln secant x divided by 2 should be the same as sine x times tangent x. So now, 2 kills the 2, and he kills ln, right? Aren't they inverses? Yeah, they are. So what do I got here? I got secant x minus. Now, this negative will go inside the ln. The negative from here will go inside ln as a negative 1 power on secant. So that becomes a cosine. So cosine x.
So you said make it this negative, we're gonna transfer it over to the negative. Or negative, negative. You know that.
Oh, yeah.
It's so much fun, right?
Oh, yeah.
So the negative from here becomes a negative on a secant. So 1 over secant is the cosine. And now we need to do some trig identities. Hopefully this can work out. Secant is 1 over cosine. So we have 1 over cosine x minus cosine squared x over cosine x. And that should be sine x tangent, should be obvious. So I have a cosine x as the common, and on top, what do I get? 1 minus cosine squared is? Very good. And then sine times sine, leave one sine aside. The second sine is sine over cosine, which is tangent. And there it is. This is what we call mathematical gymnastics.
So on a test, this problem probably was what, like 5 points?
Yeah, 5, 6 points.
Alright.
kiss those points goodbye.
He's gonna make sure he does the quizzes. He's like, forget this.
Yeah, the quizzes are gonna make, just for you, since you're. Let's go with problem 15 because we can. Let's redeem ourselves. Cosine hyperbolic x plus sine hyperbolic x is equal to e to the x. Did you say I'm gonna go ahead with the prediction? It's not true.
I had a 50-50 chance.
That's true, actually. 50-50 chance.
But wouldn't you agree that waves mess something up into the right?
You know
So it's
what's
not
messed
50-50.
up? You know what's messed up? In all the homework, everything. When it got down to adding and subtracting, that's where I messed it up. I was so mad. Like, what would be one negative?
That's standard. I mean, that's standard. How do you enjoy this? Huh?
Okay, that one was really easy. That's an idea. Sine squared x.
Okay, so sine is e to the
Good for you. You got so
So, on the last one.
What'd you get?
Oh, well, I got 1 minus b.
How's it going?
Right, yeah, that's why you have to first apply the sine squared x identity, and then you have to go back and apply your sine squared x. You have to do it inverse.
Oh, that's terrible. I thought we had a foil.
It's no so sine squared x. So you actually pull a sine x out and just make your sine x. You're right. You got a sine x. You're right.
Oh, is it too expensive? That's what you have.
What did you get when you added it?
Well, you're ready.
You will pay? You will pay?
Negative ln negative ln equals 1 over.
Luckily it's close, so you can just jump and get it. See?
I remember it's like
Yeah, that was on homework.
or the number in the front.
2 lines, right?
It's been a while. That's why I carry this thing.
So what do we have? Cosine hyperbolic is defined as e to the x plus e to the negative x over 2. Plus sine is e to the x minus e to the negative x over 2. And we need to see if that is equal to e to the x. So we have addition. That's a plus, which means add two fractions. Common is 2. E to the x plus e to the x is 2e to the x. And then these ones just cancel. All right? And you're done. The 2's drop, and there you go.
So that was we have something like this on the top.
Exactly. Like, well, how is this any easier or harder than this problem or the one before?
Well, first of all, there's the rainbow.
Really?
There's the rainbow.
I'll bring you more cookies.
Yeah, this should be.
Let's see if we can find something interesting over here. Scroll a little bit here.
I really do hope you have a slow day tomorrow.
No.
I do hope you do. Because I thought, even though I think I'll still do okay.
Did you see that the lab, or the first lab was only on chapter 6?
No, the first lab now covers chapter 6 and 7.
Okay.
All that happened in this new book is they took the old chapter 6 and they chopped off the last 3 sections, 6.8, 6.9, and 6.10, and they're calling that chapter 7.
Oh.
So the material is the same, the picture is the same, everything is the same. The homework, everything is the same, except they renamed 6.8, 6.9, and 6.10 into 7.1, 7.2, 7.3, which now pushes the chapters back.
Did you update the syllabus?
Yes.
Did you send it out?
No. I can't remember.
And when is like the
I will.
the whatever my
Please.
math lab that get fixed?
I'm sorry?
It should be fixed.
When is that gonna get fixed?
It's
I
fixed.
still don't.
Oh, we'll talk after it.
Okay.
All right, so one more, and then let's do some calculus. It will be fair.
What the hell?
So cosine hyperbolic 2x is equal to cosine hyperbolic squared x plus sine hyperbolic squared x, because you guys had some doubts whether we add or multiply or we do the rainbow.
You can manipulate whichever side you want.
Yes. In this case, both.
do it. But your exponents, they follow the same rules as exponents.
They subtract, yeah. It is like that, like 100%. There's no way to turn it on. There's no way to shut it off. And when you shut it off, you walk away, it goes up. So, I know. Yeah, I have a feeling that even if you uninstall the damn thing, it will still come back.
Oh yeah, no, I'm positive that they find a way. I've uninstalled the Windows 10 Xbox game client many times. It still there.
All right, are you ready?
No.
What do you mean no? 2 lines. What are you doing? 4? 2.
I had a few, but you can skip some steps.
All right, let's go. So what do we know? We know power reducing formulas, right?
Yes.
So we plug those in. We don't have to do this one with ease. Cosine hyperbolic 2x is equal to cosine hyperbolic 2x plus 1 over 2 plus cosine hyperbolic 2x minus 1 over 2.
Oh, I thought it...
So we just use these guys, and then these cancel.
Sugar boogies.
And we have cosine hyperbolic 2x is equal to 2 cosine hyperbolic 2x over 2. This dies, and I said 2 lines.
not if you
Oh, not if you plug in ease, huh?
yeah, not if you plug in these.
I
I had a whole bunch.
Can you plug ease? Yes, you can, but then you have to foil and do the rainbow and all that stuff.
That's where I got. I was in the middle of that.
You were in the middle of the rainbow.
Yes, I did the rainbow first, and I forgot me.
Yes.
When it says in the homework that you must use like what? Go on Google and just write the integral of
or Mathematica or Lab or from Alpha. You know the exam. Even if I know it, I'm going to
Yeah.
All right. So enough of this impossible stuff. Let's do some integrals. That's easy. Right? Like, let's do calculus. Enough of this algebra. Or is it a good time to take a break? What time class ends?
You got 20 minutes.
22. Oh, time flies when you're having fun. Wow. No break. Derivatives.
Okay.
All right. So we are ready for derivatives of these wonderful functions. And then, you know what? Derivatives and integrals. One shot. Because it's calculus, not algebra. You got this. The derivative of sine hyperbolic x is cosine hyperbolic x, which immediately means that the integral of cosine hyperbolic x dx is
Negative. What did you ask me?
plus c. Yes. Plus c. Plus c. C. The derivative of cosine hyperbolic x is sine hyperbolic x. Note no negative. And then the integral of sine hyperbolic x dx is
Cosine plus C.
hyperbolic x plus.
Oh, sorry.
Yeah.
So what are negative?
There's no negative on it.
They're going to kick in later with cos.
So these are different.
What's the derivative of tangent hyperbolic x? Exactly.
You get
Secant hyperbolic squared x, yes. Which means that the integral of secant hyperbolic squared x dx is tangent hyperbolic x plus c. Now let's go with the cotangent hyperbolic x, and this is where your negatives kick in. Negative cosecant hyperbolic squared x. Perfect. Integral of cosecant hyperbolic squared x dx is equal to negative cotangent hyperbolic x plus c. The derivative in respect to x of secant hyperbolic x is going to be negative secant hyperbolic x tangent hyperbolic x, which means that the integral of secant hyperbolic x tangent hyperbolic x dx is negative secant hyperbolic x plus c. I managed to squeeze it in. And the derivative of cosecant hyperbolic x is negative. Very good. tangent hyperbolic x, which is the integral of cosecant hyperbolic x cotangent hyperbolic x dx is equal to negative cosecant hyperbolic x plus c. There. So note that the negative sign for the derivative of cosine is gone. We gain the negative sign on the secant, the fifth one from the top. But we still see that the general, rule of the pairing, if you remember your trig integrals and derivatives, they were paired, sines with cosine, secant with tangent, and cosecant and cotangent. Now the pairing is still the same. Sine hyperbolic with cosine hyperbolic, secant hyperbolic with tangent hyperbolic, and cosecant hyperbolic with cotangent hyperbolic. So the pairing is preserved, and you just have to be careful with the minus sign. So the minus sign used to be here, and now is there. The rest of the minus sign work the same as they were before. So these two just swap the minus signs. So problems? Of course, right? What is the derivative of secant hyperbolic square root of x? It's getting there.
Let's see.
Derivative.
There you go.
1/2 square root of x to the minus 1/2.
That's the one. We have a chain rule. Exactly. So you had it right, and you just had to divide it by 2 root x for the chain rule. So, as you know, coughing, look at this secant hyperbolic. That gives us this. Since our input function here is root x, then root x has to go for these 2 x's in there. And then we have to multiply it by the chain rule, which is the derivative of root x. So now, what do I have? I have negative secant hyperbolic root x tangent hyperbolic root x divided by 2 root x. Can I cancel root x?
No.
Oh, you said so. No. It's not no, it's hell no. The difference between the two. You cannot cancel because these root x's are buried within the hyperbolic functions, and this one over here is free to roam the universe.
Still put a plus.
You put plus c just in case. Let's see what the book. Oh, beautiful! Look, wow. This is from your textbook. Their idea of fun. Ready? X tangent hyperbolic x. What now? Easy? That's what I like to hear. Have a cookie. No? That's fine. More for me.
the square root.
All right, so what are we using now?
You know, the multiply.
Yeah, the multiply rule. The product rule, yes. This is when you're so stressed anymore.
It's like how you reduce to the simplest fraction, you reduce to the simplest words.
Yes. Copy the first, derivative of the second,
Yes.
plus copy the second, times derivative of the first, just 1. There we go. Got it, right?
Did I get it right? Yeah. You can put that on.
Do I have your permission?
Angela just making up the test for you.
How about this? On a green paper. All right, one more derivative and then we can finally start integration. All of the problems in integration are going to be U sub, right? Hard. No, it's hard. You guys are really funny. What's taking so long? Chop, chop.
Oh, okay.
I took out, because you've got 2 cosecants.
Yeah, I didn't take anything. I didn't reduce it. Everything's staying just like that. I'm not.
Because when you start doing algebra,
No, that's when I mess everything up.
things immediately explode, right?
Yeah.
So just leave it. So back up, leave it.
Yes. Leaving it like that.
Leave it like that, slowly back it up, back it up.
You won't make pocket wrong, will you?
No, I won't.
Okay, good.
Unless you want me to.
No, thank you.
Which is that? Plus the first one times the derivative, which is 1.
Who got what?
Nice. And the same thing here.
You guys are so funny.
This is what I got.
That's too complicated. Too complicated.
Why is it complicated?
Ready?
I didn't reduce anything.
So what do we do?
Quotient rule.
Why?
I did quotient rule.
What do we do? That's it, man. See? Yeah, exactly. X times sine hyperbolic x, and then we just do the product rule. Noobs.
Why would you do that?
Because who wants to do quotient rule if you can do product rule?
It's too late. I already did it.
It's too late.
Just say it like that.
Copy the first derivative of the second, cosine hyperbolic x, plus copy this one, sine hyperbolic x. Walk away, walk away, walk away. Nice! You love when the problem starts with the word prove, right? So how about you prove that the integral of sine hyperbolic x dx is cosine hyperbolic x plus c?
This isn't anything. Why are we proving things?
This what? It's not what?
This isn't an honors class.
This?
Because you said proving. But we're not doing the proofs. We're just
Oh, these are the fun proofs. These are calculations. There we go.
Yeah, that's right.
What?
It is proved.
Nope.
What?
Yeah, exactly.
Oh, it's the integral. See? See what you did?
I haven't done anything yet.
Okay, sine. Oh, we have to integrate both sides?
Just integrate left to get right. What's the key for this problem? What are we supposed to do?
Use the E.
Yes, use the E definition. Replace that and then just integrate those. Integrate them E's.
Just so
That's-
stupid here. That's all I gotta say.
Now, if you have trouble with this, you can split two fractions, right? Like this. And then you integrate each one separately. This one stays the same. Minus the other one becomes minus c to the minus x over 2. And then we have plus c. So now you have e to the x. Minus and minus gives you plus. E to the minus x. Common denominator is 2. Plus c, which is, when you have a plus, it's a cos hyperbolic x plus c. Done. How about some serious integration? Problems 37 through 56. let's start on an easier side. Problem 44. So integral 0 to 4 of secant hyperbolic squared square root of x divided by square root of x dx. This one should be obvious. What do we do? You sub, nice.
Is hyperbolic tan under x the same as tan under x? No. How do you calculate? Like once you need to plug in the limits.
Ease.
Oh, to the ease.
So we have that u is equal to square root of x and du is, very good. So now I need a 2 and a 2 on top. So 2 integral 0 to 4 secant, no 0 to 4, I have to change that. Secant something, secant hyperbolic squared u du, and square root of 0 is 0, square root of 4 is 2. Nice. What's the integral of secant square? Tangent hyperbolic u from 0 to 2. So this is 2 tangent hyperbolic 2 minus 2 tangent hyperbolic of 0. Now, tangent hyperbolic, if you think about it, tangent hyperbolic x was sine hyperbolic x over cosine hyperbolic x, which means that I have 2 and the sine hyperbolic of 2, you can do it that way, or you can just plug your e's. So e squared minus e negative 2 over 2. Not over 2, sorry. Over e squared plus e to the negative 2. They're much better. Minus 2 times e to the 0 minus e to the 0 divided by e to the 0 plus e to the 0. So e to the 0 minus e to the 0, this whole term is 0 now. No coffee. And that's it. We can just leave it there. You can make it nicer if you multiply by e square, but nah, whatever. See? Time flies when you're having fun. 2 hours. This. Bye.